Hello students, it is nice to once again meet you through this video. We are in the 12th chapter of physics of class 11. The topic is gravitation. We already done one lecture. Hope you saw the previous video. We saw about Kepler's laws of planetary motion, and as well as we also saw about the Newton's universal law of gravitation. So today we're going to start with the next topic of gravity. So what is gravity? This is something to do with the location wherever you are. If you are there in a particular planet, then you will experience gravity. So it is something to do with the planet, and it is something to do with the force in which it will be exerted. So already Newton said, if you have one body here and if you have another body here, this is M1, this is M2, these two bodies will definitely have a force. So this body will have a force F1, this body will have force F2, and this is in a distance of R. So any two bodies in the entire universe will have a force. What is the specific name of gravity it is given here is because of a huge body of a planet. Maybe Earth is a planet here, and our tiny speck of a body which is standing on the surface of the Earth. This body called small m and the next body called capital M will also have a force. Force of any two bodies is there, that is Newton's universal law, and this also will have a force. This small body will have a force with the big body, because big body will try to pull it with an attraction. So that force of attraction towards the center of a planet is called gravity. So Earth is the planet that we are all living. So it is gravity due to Earth. If you go to moon, gravity due to moon, because any body on the surface will be pulled towards the center with a force. So gravity means force, and it is a pulling force always. It is an attractive force. And which direction? Towards the center. Towards the center. So it is very clear that it is a force. It is an attractive force. It attracts the body towards the center of the planet. That is called gravity. So look at this one. Gravity is a force. So gravity is a force with which Earth attracts a body towards its center. Okay, so you can take a look on this. Now, moving further to the next topic of acceleration due to gravity. So what is acceleration? That means when you drop a body from a particular height towards the surface of Earth, this is the radius of Earth, then the force which is pulling it out, down inside, will go in an increasing speed all the time. When the velocity is at rest and the velocity keeps on increasing towards this direction, that means it is accelerating. That acceleration towards the center of the Earth is called acceleration due to gravity. So acceleration due to gravity is a rate of increase of velocity of a body falling freely towards the Earth. So that is what g means. We call it a g. It is just an acceleration. So g means meter per second square, with it will be the SI unit of this one. So the change in velocity per unit time. Now let us consider, we need to find out the expression. So we are going to see some consideration. Let us consider, you can write down, consider a body of mass m placed on the surface of Earth. body of mass m placed on the surface of Earth. Okay. Now, what is the distance it is there? Okay, the distance is equal to r. Now, what is this r? It is the radius of Earth itself. So, this body is kept right on the top of this Earth. Okay, so this is the radius of the Earth, and mass of the Earth is me. So mass m is there, place it this one. Okay, radius. So what happens? So the force experienced by the body F is going to be equal to G into capital ME small m into RE square. G into mm, m1, m2 upon r square. What is r? The radius of the Earth itself. And what is the mass? Mass of the Earth is this me. So two masses are there. One is Earth and next one is this tiny body of mass m. This is equation number 1. Alright. We know force of gravity F is going to be equal to m into g. This also we know. This is equation number 2. The force of gravity is m into g. Now this force is actually this force of gravity. Also mass into acceleration due to gravity. Force is always equal to mass into acceleration. So you can substitute both this value. Mass into acceleration is Newton's second law, and this one is Newton's universal law of gravitation. So these two things, both of them proposed by Newton, has to be equated, because there is also force, mass and acceleration, there is also force. So having this one, so it's going to be equal to G times of me small m upon re square is going to be equal to m into g. So mass gets cancelled. G is going to be equal to G me upon re square. This is the expression. So G is going to be equal to, when we put the values here, G is going to be equal to 6.67 into 10 to the power of minus 11, right? So it's going to be equal to Newton meter square per kg square, and mass of Earth, it is 6 into 10 to the power of 24 kilograms. These are all constant values. Radius of Earth is 6.4 into 10 to the power of 6 meters. Putting all those value, 6.67 into 10 to the power of minus 11 into 6 into 10 to the power of 24 divided by 6.4 into 10 to the power of 6, you have G is going to be equal to 9.81 meter per second square. So you will get this value. So this is the way in which we could find the acceleration due to gravity. So please note down this small derivation. The small derivation is very important. Note, this is a very, very important formula. G is equal to capital G m upon r square. It is not only the G is going to be equal to force upon mass also. This is also another thing, the force per unit mass. But this is also another very important formula that comes in. Okay. So we'll go to the next topic now. Now the second thing is, how does gravity vary due to different parameters? Number one is variation of gravity due to altitude. What is altitude? This is the Earth, and you go above the Earth, go for a height h, and this is a radius already. What will happen if you go and stand here? What will happen to the variation of gravity? Second part, due to depth below surface of Earth. if you dig it down and go here, you've already gone for a depth d, and you're standing here, what will happen to gravity? Due to depth, and this is due to altitude. Third part of it, due to rotation of earth, or you can say instead of rotation, it is called latitude. Latitude, because earth is also rotating. When earth is rotating, you are putting a body here, this body also will start rotating in this same orbit like this. Because this body is already on the spinning thing of the earth, is there any changes? So rotation of the earth also need to be taken. And then the fourth point is due to shape of earth. So shape of the earth means we know earth is not an exact spherical body, it is like this. We know earth is like this. So if you are standing here, this is equator, and if you are here, this is a pole. Now this RE to the equator and RP is not same. We need to see that also because of the shape of the earth. So there are four variations: altitude, depth, rotation, and shape of the earth. So we need to see how it could move forward. So we are going to see one by one. Remember, each and every part is a big derivation. This is a big derivation, this is another second derivation, this is a third derivation. This is not very big, but all the three are very, very important big derivations. So we are going to see one by one. So let's go ahead and start with this derivation. Alright, so variation of acceleration due to gravity. The first part is effect of altitude. Now draw this diagram here. We have earth. So this is the radius of the earth. Put RE, and let us consider a body of mass m at a height h from the surface of the earth. Okay, so it is there on the height h above the surface of the earth. Consider a mass m at a height h above the surface of earth. Let RE be the radius of earth and ME be the mass of earth. So what happens to the two important points? One is this body was there earlier on the surface of earth. Now the body is there at the height h. Okay, so when the body is placed on the surface of earth, what happens? G is going to be equal to capital G, we already know, capital G ME upon RE square. This is the acceleration due to gravity when it is there right in this point. So this is equation number 1. So the next thing is when the body is at height h, then G dash is going to be equal to GME upon, now look at this height distance from the center to this point. What is the total distance? It is going to be equal to RE plus H. That is the total distance. So it's going to be equal to RE plus H the whole square. This is the second equation. So there are two equations which is here, when it is at the surface and then when it is at the height h. So there is a variation here. Now it is called as G dash. Please look at this one, G dash. Why it is G dash? Because the height is increased. When the height is increasing, this entire part is increasing. When the entire part is increasing, obviously this is going to come down because it is inversely proportional. So we need to compare what will happen between these two things. So dividing 1 and 2 from 1 and 2, G dash upon G is going to be equal to, so 2 divided by 1. So GME upon RE plus H the whole square upon GME upon RE square. So that's the way you get it here. Now these two gets cancelled out. It immediately goes away. So G dash upon G is going to be equal to RE square upon RE plus height the whole square. So that is the value you get here. We can also take RE outside of the bracket. It is RE square is going to be equal to RE square 1 plus H upon RE the whole square. That is G dash upon G. Now these two gets cancelled out. So you get only this as the value here. Now in other words, G dash is going to be equal to G, you cross multiply up there, G upon 1 plus H upon RE whole square. Now if you look at this whole value here, this will be a value which will be having its own thing because of the height here. Because of the height here, this will be increasing. This entire thing will increase because as height increases, this whole thing will increase. Because of this whole thing increases, this will decrease. So from above equation, G dash, which is bigger? G dash is bigger or G is bigger? G dash will be less than G. Because this height is increasing, this whole value will increase and G dash will get less. And it will get less, so G dash is less than G. Please remember this one. Okay, so you get here a fraction of the value here. So what the conclusion it is? When you go above the surface of Earth, in the height h, acceleration due to gravity will decrease. Therefore, G decreases with altitude. When you go above, G will decrease. So that is the conclusion here. Now, this is a very, very important equation. Equation number 1, I can say. Equation number 1 for this particular derivation. Now, we need to also look at this whole thing as a reality check. What is a reality check? If you look at the whole Earth from here to here, what is the distance here? This distance is 6400 kilometers is the standard value of the radius of the Earth. You start digging down, you go down till the center of the Earth, it is 6400 kilometers. Look at this one, it's really big. 6400 kilometers is from the surface to the middle. Now whatever the height you put up here, maybe you say I went for 20 kilometers. 20 kilometers if you go, even the flight, the jet aeroplane, it flies around 20, 16, 18 kilometers it flies above the surface of Earth. That is the height in which they have given for the thing. Now this 20 is nothing when compared to 6400 kilometers. So whatever the height you are telling, the reachable height for anybody to reach, even if it is 100 kilometers, the height is very, very negligible. The height is always negligible when compared to the surface of the Earth. So we are coming up with another thing. When the height is negligible compared to radius of Earth. So what will happen when you are having the height, and the height is not so much when compared to the radius of the Earth? Now we'll again write the same value here, g upon 1 plus h upon re the whole square. Now here height is less than re, very less, negligible when compared to the radius of the Earth. So g is equal to g dash is equal to g times of, take this to the top, 1 plus h upon re the whole square. It will be whole square or minus 2 because it has gone up, minus 2 will be there. Now when it is in the minus 2 here, since height is already in this particular purview, it is there, height is very less than re, we have to apply a theorem called Binomial Theorem. Binomial Theorem always applies to the fact that 1 plus a value which is very negligibly small. Height upon re, maybe it is 10 km upon 6400 kilometers. How the ratio will become? 1 upon 6640, it will be very less. Even if you have 100 upon 6400, so this 2 gets cancelled. 1 upon 64 is going to be a very small value. So applying Binomial Theorem. So Binomial Theorem, what it says is, do the same way, 1, then you need to have plus. Instead of plus, what are you going to do is, we are going to definitely, okay, you can put a plus also, but this minus 2 will get multiplied with this one here. So I can get minus 2. It just comes here. The power will come to this place. And then height upon re. Alright. So the power value will get down to this point. And then to the power of 1 it will become. Alright. So this value is now getting added here. So once this is the value here after applying Binomial Theorem. Now look at this one. G dash is equal to G minus 2GH upon RE. Other words, it's going to be G minus G dash is going to be equal to 2GH upon RE. This is the value. Now even at this point of time, if you look at this one, G minus G dash, so which is bigger? This is bigger. Minus G dash is going to be a positive value. So here also G is greater than G dash. Okay, and the value is very clear. G minus G dash is going to be equal to 2GH upon RE. But at this time, it is only RE, it is not square. Are you able to see this one? It is not square. Whereas the previous derivation, it was, the whole thing is 1 plus H upon RE, the whole square was there. So now, it is just RE. So this is the second equation. When it is above the surface of Earth at a sizable distance, not very high, negligible compared to the surface of Earth. Alright. So with this derivation gets over. There's one more, you can say case 1. When the body is placed at height h equal to radius of Earth. Height is going to be equal to radius of Earth itself. So what will happen here? If you go to a place, this is the RE, exactly here you go till this point here, the same RE is there. Okay, so you need to put this, for this one it is not negligible, it is quite a bit height, 6400 is also 6400. So which one it has to put? So going for the first equation, G is going to be equal to, G dash is going to be equal to G upon 1 plus H upon RE the whole square. So here H is going to be equal to RE. Put this value. So G dash is going to be equal to G upon 1 plus RE upon RE the whole square. So what you will get here, finally you will get here as G by 4, where this will get cancelled, it will become 1, 1 plus 1 is going to be equal to 2, 2 square is going to be equal to G by 4. So at this point of time, what will be the acceleration due to gravity? It is 9.8 divided by 4. That will be the acceleration due to gravity. And also we need to draw a graph for this. So what the graph you can draw is, so what happens when you are there going above the surface of Earth? So when the height is increased, what will happen to the gravity? So what will happen to the gravity is, gravity from here, it will keep on reducing and it will go on like this. So G is inversely proportional to R square. You will find it is the inversely proportional to square of the radius, square of the distance. That's what you will find here. Okay, and what is this one? It is 9.8. The value here is 9.8. This is at the surface of Earth. Surface of Earth. That is this point that we talk about. And then it is going above height. And how this one variation will be? Variation will be like this. Alright? Okay. Alright students, I am just closing here. If the next derivation I start, then it will take quite a lot of time. So what you will do is, you will turn to page number 528 and read the very short answer type questions. There are 8 questions are there. Please read them. Try to answer it. These are all based on Newton's law of gravitation and Kepler's law. So that will be pretty more helpful for you. And then if you could also continue to read question number 9, 10, 11, 12 and 13. So these are the questions, and also 14th also. 14th also, please read this one. So till 9 to 14 also you read the question. That's the homework for you. You will be able to have much more clarity on what you are talking about. And please read the book also, page number 487, and read this one, how it has been clearly explained. And we already saw about G by 4, how it will be there at a place exactly equal to the radius of the Earth at the height, how it will be. And then we also saw this one, how it is going to reduce, and the graph also we saw. So please make sure you try to take a full look on all of them. Alright, so with this I close. The next class I will deal with the next 2 things. Thank you.